All right, this is going to be a quick video. For those of you that weren't here, couldn't make it, we're going to just show a couple things that are going to be reviewed, and we're going to intro the quadratic formula. So it's important that you see this, I think, especially if you weren't here. So solve the equation by completing the square. This is review. There's 3 steps in completing the square that we need to do. And when we complete the square, we put it in the form of f of x equals a x plus or minus h squared and plus or minus k. So a, h, and k. I need to know what a is, I need to know what h is, and I need to know what k is. It looks like a b, that's an h. Right? I need to know what those are. Well, the very first step in converting from standard form to vertex form is divide a, move c. M-O-V-E, move c. So how do I divide a? Well, I'm going to divide a out of the first 2 terms. So 3, it's going to give me x squared minus 2x plus something minus 4 equals 0. I left a little space in there on purpose. So divide a, move c. At this point, I know a. If I'm dividing a, I know a is 3. A is a no matter what form, so as I begin to build the equation, there. Step number 2, I'm going to find h. Well, what is that? That's take half of b and square. I'm going to take half of my new b value, which is minus 2, and square it. Minus 2 divided by 2 is equal to negative 1 squared. That's my h value. Negative 1 squared is 1. Okay? So I know AH, but remember when you take h and plug it into the equation, it's minus h, so minus a minus 1 is plus 1. And then k, how do I determine the k value? That's step number 3. Step number 3 is I'm going to add in parentheses and I'm going to subtract out of parentheses. That's my step numbers, that's what we talked about. So I'm going to add 1. How much am I really adding? I'm adding 3, so I must subtract 3, so that's minus 7. So there's your k value. You converted. So now we're going to take this 3 times x plus 1 squared minus 7, and it says use this to find your line of symmetry. Well, the line of symmetry is the same as h, so x equals negative 1. And then it's saying the distance from the line of symmetry to your x-intercepts. Well, imagine if I had a graph and I had that line of symmetry, and I had a parabola on that graph. It wants to know this distance right here. It's calling that d. That distance is the same on the right and left sides. So if that distance is the same, and I know it at these 2 specific points, I have a number, I went out a certain number, but I did not go up and down, that's a 0, that's an output of 0, I'm going to use that to my advantage. So 3 times x plus 1 squared minus 7, and I'm going to go ahead and solve. I'm going to add 7 to both sides. So 7 is equal to 3 times x plus 2 squared. Yes, I'm going through this fast, but this is video. This is review. If you need to, you can pause. The next thing I'm going to do is divide by 3, and I'm going to get 7/3. Don't mind that. I'm going to get 7/3 is equal to x plus 2 squared. And you're freaking out because of the fraction. Don't freak out because of the fraction. The next thing I do is I got to get rid of the exponent of 2, so I take the square root of both sides. Whenever you take the square root, you get plus or minus x plus 2, and I subtract, oops, that's 2. It needs to be a 1. I got to go back, I caught myself. Needs to be a 1 there, needs to be a 1 there. I saw the square, I'll fix it. 1, 1, 1, so minus 1. I'm going to minus 1 on both sides, so therefore I get minus 1, or x equals minus 1, plus or minus the square root of 7/3, not 3/7, 7/3. What is this telling me? Well, a radical, if it's not perfect, a radical is a decimal, right? So this is telling me negative 1, I'm going to go a decimal number to the right and a decimal number to the left. That's what's going to happen. If you were in class, you saw how we used the calculator to determine that. If you missed it, hit me up, I'll explain it to you. It'll take a couple of seconds, right? Then we move on and we go through this process when we look at this right here of completing the square. The process doesn't change. If we complete the square from standard form to vertex form using only a, b, c, not numbers. We just did it with numbers. If we use it using a, b, and c, we get minus b plus or minus the square root of b squared minus 4 times a times c all divided by 2a. We end up with the quadratic formula. There you go. Right? I'm not going to bore you with all that. What is the equivalent expression for ax squared plus bx plus c? It is the quadratic formula. That is the equivalent expression. What is the line of symmetry? The line of symmetry is x equals minus b divided by 2a. That is the first portion, or that is these two pieces right here. Because you have to remember, this 2a is a common denominator for minus b, and it's a common denominator for the radical as well. And then what we did is we went ahead and we practiced a couple of these. I'm only going to do one of these with you on the video because you won't sit and watch two of them. Last semester we had a couple of exam sections where we found a, b, and c. A is 1, b is 5, and c is 1. Right? A, b, and c. A and b are the coefficients of x squared and x, and c is the y-intercept. So now I'm gonna stress this to you. Okay? Again, I'm only gonna show this to you once. Find a, b, c. Next, you go ahead and write your quadratic formula. Where you see a, b, and c, you use parentheses. So minus b, I'm just going to write some parentheses. Plus or minus, I'm going to draw a square root sign. B squared, I didn't write b, I just wrote parentheses. Minus 4, that's a constant. Times a times c, using parentheses, all divided by 2 times a. Why do I use the parentheses? I use the parentheses because I think the book should, the book doesn't, and from experience, if I didn't draw the parentheses, I would make a lot of mistakes. Now that I drew the parentheses, now I can go ahead and put a where a goes, b where b goes, c where c goes. Minus b, so that's a 5, b squared, that's a 5, 4 times a, which is 1, times c, that's going to be a 1, 2 times a, which is a 1. I can go back and put in my b's, 5, my c's, 1. Now this looks like a monstrosity, but I can simplify this pretty quickly. It will condense rather quickly. In a couple of quick steps, you'll see how it condenses. Well, minus a positive 5 is minus 5, plus or minus the square root of 5 squared, which is 25. Here's another step. Are you listening? Are you focusing? Are you paying attention? Here's another step that I always struggled with. Is it 25 plus or 25 minus? Well, a negative times a positive is a negative times a positive is negative, so it's 25 minus. Done. I don't have to guess anymore. 4 times 1 times 1 is 4. So now I can go ahead and finish. 2 times 1 is 2. The next thing I can do is 25 minus 4. So I get x minus 5 plus or minus the square root of 21 divided by 2. That could be an answer. But because I don't like radicals and we like better with decimals, I'm going to go ahead and convert this to a decimal. What is the square root of 21? Well, we used our calculators to approximate it. The square root of 25 is 5, so the square root of 21 should be less than that. And we'll say approximately, we'll just call it 4.5. We'll call it even. So in this case, x is going to be equal to minus 5 plus 4.5 divided by 2, or minus 5 minus 4.5 divided by 2. We're going to have, remember, since there's a radical, there's 2 possible answers. And we can go ahead and we can do this. This is going to be negative 0.5, I believe, divided by 2. Should be. And this is going to be negative 9.5 divided by 2. And in class, we used our calculators to find a definite answer. So if this is a definite answer, minus, use my glasses here, minus 5 plus 4.5, got to hit the equal sign, which is minus half, before you divide it by 2. So we're going to divide that by 2, and we get minus 0.25. That is one answer. Our other answer, again, how you would use this on a calculator, minus 9.5, minus 5 minus 4.5, minus 9.5. Okay, now we want to hit divide by 2, and we're going to get minus 4.75. That's our other answer. Those are the actual x-intercepts. My line of symmetry is right here at negative 2.5. So if I look at this from a graphical standpoint, I'd come out here, this would be negative 2.5, right? Because half of 5 is 2.5, right? And then I would go out to negative 2.5 or negative 0.25, which would be like negative a quarter right there, and 4 something. Something like that would be my graph. It'd be around in there somewhere. Not asking you to do that. We'll finish the other 2 tomorrow in class. Another video coming.